An electrical current is defined as the number of electrons passing a given point in a second. And voltage is defined as the difference in electrical potential energy per unit of charge between 2 points. To explain this further, let's say we have a body of water, with a pump drawing the water up to an elevated tank. Right now, the water tower has a lot of potential energy to do work, but it isn't yet releasing that energy. So now let's connect another pipe to the tank to complete the circuit and produce a current. In this example, the flow of water through the pipes can be thought of as the current, and the total stored potential energy of the water in the elevated tank can be thought of as the voltage. If we made the pipe larger, the potential energy, or our voltage comparison, would remain the same, while the current would increase. And if we remove the second pipe altogether, there would no longer be a current, but the potential energy, or voltage, would again remain the same, in the same way that a battery has a voltage associated with it, even if it's not currently connected to a circuit or doing any work. Now, in the original definition, we also said that the voltage was the difference in electrical potential energy per unit of charge between 2 points. So back in the example, when we were talking about the potential energy, what we're really referencing is the force of gravity pulling the water from point A to point B. The potential energy, which again can be thought of as voltage, would rise if we increase the difference between the 2 points. Voltage is always in reference to a difference between 2 points. Even when we're talking about a 9-volt battery, what we're really saying is the difference between the 2 terminals is 9 volts. With electricity, rather than in the previous example where gravity was the applied force, it's instead the electromagnetic force. The electromagnetic force is the repulsive or attractive force between electrically charged particles, and in the realm of electromagnetism, opposites attract and similarly charged particles repel. If we take a conductive metal wire and complete the circuit with a battery, the electrons from the negatively charged side of the battery will be attracted to the positively charged end of the battery at a force equal to 1.5 volts in this example. Without voltage, the electrons will move randomly in all directions. Voltage is what pushes electrons around a circuit. So to summarize, current is simply a measurement of the flow of electrons passing a certain point. And voltage is the electrical potential difference between 2 points, and is the driving force within a circuit.